welcome to my channel. My name is Ifora Kuchuku Patrick, um, and today I'll be talking about something that has actually changed the face of security on web browsers. It's an aspect of web security for the web platform. And by web platform, I mean web browsers. In general, it's highly supported across multiple web browsers, and it's used to boost security for web pages, um, well, either on the front end or on the back end. And it's called content security policy, which is what we have here. Okay. So, as the name implies, it's a compound word, made up of three individual words: content, security, and policy. So security being, a word in that compound word signifies that it has to do with security, and it has to do with web security. So a very basic definition of what it is. Um, so content security policy, short, CSP, is a feature that helps to prevent or minimize the risk of certain types of security threats. It consists of a series of instructions from a website to a browser, which instructs the browser to place restrictions on things that place restrictions on the things that the code comprising the site is allowed to do. The primary use case of CSP is to control which resources, in particular, JavaScript resources, um, CSS resources, image resources, font resources, all those resources, um, where they are loaded or whether they are even allowed to load. Um, the main use, this is mainly used as a defense against cross-site scripting attacks, in which an attacker is able to inject malicious code into the site. A CSP can have other purposes as well, including defending against things like clickjacking, um, uh, and to ensure that a site's pages will be loaded over HTTPS. So that's basically what we don't need to read further. We'll go into some of the examples later on, but this is kind of like a very long academic definition of what content security policy is. Again, just backtracking, if you don't know what clickjacking is, there'll be a link in the description. So just check that out. If you also don't know what cross-site scripting is, there will also be a link in the description. And I think this is a very good time for me to say, please, if you enjoy this video or any of the earlier videos that I've done, um, I'm getting used to this YouTube thing. Don't really know much about it. I'm just getting used to it and making content for people. So if you like what I say here, if you like the kind of content that I put out, please consider liking this video and liking some other of my videos, watching and liking other of my videos, and also subscribe, if you can, so that I can be able to do more of these videos and get some of these things broken down, explained, and very well um, demonstrated to you guys. So yes, I'm going to be going into a demo of content security policy. This video is part one. This is part one. So this content security policy, expose, you might call it that, is divided into two parts. So this is part one, and I'm going to be covering part two separately. But one of the things I want to say, which is how I have split the video, is that part one will cover one way. So there are two main ways to actually deploy content security policy. Two main ways. One is with a meta tag, which I'll be covering extensively. in this part one video. And the second is a HTTP response header, all right, which I'll be covering in the next video in part two of this content security policy expose. All right, so we're going to get right into it soon. But before we do, um, this definition, everything that has been read here so far, is basically a very, very academic, definition of content security policy. And yeah, lots of words, not really, especially if you don't know what cross-site scripting is or clickjacking is. But there is no real, you know, uh, basic definition that you can relate with, and I understand that. Um, what you need to know about content security policy beyond this academic definition. So I would give a much more simpler one. What you need to know about content security policy is that it's a whitelist. It's basically a whitelist of URLs. That's what it is. That's how it operates. It's a whitelist of URLs combined with directives. So there are things we call directives, right? And you can see it here, it consists of a series of instructions. The instructions are the directives from a website to a browser, right? So that's really the major part of the definition, right? That you need to know, which instructs the browser to place restrictions on things. Well, the things is basically just URLs. So the instructions or these directives, as I've said, place restrictions on URLs that can be communicated with by the website. All right. So if let's just take a quick primer or refresher on what a URL looks like. Um, so yeah, you have this, and this is part of the URL. So just a URL structure. Well, basically, I kind of you know lied a bit when I said it's a whitelist of URLs. Much more correctly, it is a whitelist of origins. All right. So an origin. So this is a URL. This is everything here. This is an example of a URL. Yes. And it has https blog.hubspot.com slash marketing slash part URL. So you can see that there's a color scheme here that shows the different parts. So this first part is what you call the scheme or the protocol. This is what you call the subdomain, which is the next thing here. This in orange is also what you call the second level domain, and this is what you call the top level domain, and this right here is what you call the port. Then you call this uh, subdirectory. You can also call it the path name as well. Everything here from slash marketing slash parts, and then you have the query parameters, and then you have the fragment, which is this right here, or what you call the fragment identifier. So from the part name down to the query parameters and down to the fragment identifier or the hash, what you call the hash, is really not important in content security policy. What's important is the origin, which is the protocol or the scheme, the subdomain, second level domain, the top level domain, and the port number. That's what's important. Okay. So yeah. Now, I guess we'll just be taking an example of what content security looks like. What kind of like an example of what it looks like, what it really looks like. So here's how we can do that. So yeah, so this is an example of it. This is content security policy as a HTTP response header. Remember, I said that you can set up content security policy in two ways. One as a meta tag and another as a response header. So this is it as a response header. But we're not going to go into details with this, but I just want to show you. Let's just forget about this part for a moment. I just want to show you the structure. So these are what we call um, uh, directives. So this default SRC is what you call a directive. Remember, I spoke about directives with content security policy. This is what you call a directive, and this is what you call the value of the directive. All right. So directives are kind of like what you might say instructions uh, that are properties that have values that you can set them to. So you can set different directives to have different set of values. Now those values can be um, singular, can just one value, or it can be multiple values. As you can see here, you can see that default SRC is set to self and image SRC is set to. Now, remember I said content security policy is a whitelist. It's a whitelist of origins. Now, self is basically just a short form of the origin of the current page, right? So the protocol or the scheme and the host name, right, which is the subdomain, the second level domain, and the top level domain, as well as the port number. So self is just kind of like a shorthand for the current uh, origin of the web page that you're on, which can be anything, anything you set it to, anything you set. So when you do, when you buy a domain name and you go to a domain registrar and you set things up and you set up like an A record for your server, and then you point your IP address. So you go maybe to a pass, something like a Linode or um, DigitalOcean, and you get an IP address and you set that to the domain. So you point that domain to that IP address. Um, that domain is basically what self represents. Now, another thing that is to be noted is, so this image SRC, again, it's another directive. So you have two directives here, default SRC and image SRC. I'm going to break down what those two directives mean. All right, there are a couple of them. There are a couple of directives. It's beyond two. I think there are as many as, I would say, 15, 20, 25. Yeah, but it's okay. Like I said, the main thing you need to remember is that content security policy is a whitelist. All right. So self default SRC is what you might consider to be like an all-encompassing you know um, bucket for all the origins or all the URL origins that are allowed by the web page. So self is here. You can list more. You can just separate them with a space and list more. Um, like for instance, image SRC here, self. So which means you can load images. So this IMG SRC is image SRC. So this is what domains or what URL origins can we load images from. So we can load images from self, which is the URL origin of the current web page. And we can also load images from example.com. Now, notice here that it's just the second level domain and the top level domain that is notified here, which means it can be HTTP example.com or HTTPS example.com. So you can omit the protocol or the scheme. You don't have to put it. You can also use a wildcard character, but it's not in this example. But we're going to see examples of that really very soon. You can use a wildcard character to signify subdomains. So you can see this one is just the second level domain and the top domain, but we can also use a star wildcard character to signify subdomains. So you can load images from self and also from example domain, but you can load anything. So that's what default SRC is. Default SRC is where can you, by default, where can you load anything from for the website? And by default, you can load it from self. So you can load images, scripts, which is what default SRC is about. It's about any kind of resource, maybe a video or audio file or scripts or CSS or SVG images or font files. Yeah, you can basically have like a list of URL origins where you can load those things from. As you see here, the two directives. This is set to self, this is set to these two values, as I've explained. The first directive, default SRC, tells the browser to load only resources that are the same origin as the document. Like I said, self is the origin of the web page, unless other more specific directives. So um, the way you can think of default SRC is that it is coarse grained, while image SRC is more specific, more fine grained. All right. So this is kind of like a more encompassing bucket for URL origins, and this is more specific, pertaining only to images. So that's really you know um, what you need to know. So right now I'll be showing you how to set up content security policy as a meta tag, and we're going to be looking at a much more robust example with an actual web page uh, of this, so that I can really just walk you through what it's like. All right. Hi. Okay. So we have come to just a very basic HTML file. So this is how I'm going to expose and demo uh, one of the ways in which you can set up content security policy. So like I said, there are two ways. One is with a meta tag. Uh, we have a web page here, and the other, like I said, is with HTTP response header. So if we look here, we can see a meta tag, HTTP equiv of the attribute of content security policy. And then we can see the content, and we can see, a directive similar to the example we saw earlier on the MDN website. And we can see other directives here. And we can see that each directive followed by one or more values, okay, for those directives is punctuated or delimited by a semicolon. And, we'll see more of that here. So I think we can just hide the body tag for now. We don't really need to go into that. We just hide the body tag for now, and we can focus on this. So, like I said, a meta tag is one of the ways in which you can set up content security policy, and we have that here in the head section. We have very, you know, um, popular, or I would say very um, basic meta tags rendered here for the char sets, character sets, robots file, you know, and all of that. Uh, web crawler instructions, basically. And then we have HTTP2 link for pre-connect. Again, uh, explaining what this pre-connect link tag is beyond the scope of this video, so I'm just going to skip that. We have the famous viewport meta tag. And yeah, we have this supporting IE. I think I can just delete that since IE is really no longer supported anyway. And then we have a couple of script tags with an SRC pointing to a URL. And we have a bunch of link tags also pointing to CSS files. Everything here is pointing to a CSS file. Forget about this, you know, this attribute being set here. Um, I'm not really going to go into that. Um, just it's just treat it as just a link tag, you know, loading CSS files. And we also have preload, HTTP2 preload, but this time loading scripts, three of them, and then the title tag, and then other stuff down here, and all of that. Now, let's go back here. Um, so let's take a look at the details of the um, content security policy instructions that are set here. Now, like I said, um, content security policy is a whitelist. It's a whitelist of um, directives, or sorry, it's a whitelist of URL origins, basically. And one very good example is that you can see this. This is a directive for script SRC. SRC is short for source. So this refers to JavaScript, so script sources. And you can see the first value here, separated by, this single space. Although it could be multiple spaces, but a single one or more spaces would work just fine. And you can see this points to an origin with a scheme or a protocol, HTTPS, and then the actual host name and all of that. And then we have another value for self. Remember, self is you know the URL for this particular page. I'm going to open it up in a browser later on so you can see what is rendered here. But just before I finish up with this self value for this particular HTML file, so remember this is a HTML that I don't have any um, front end UI frameworks or libraries here. It's just raw HTML markup, CSS, and JavaScript, and just a HTML file. So I've set up Kadi server, and this is what we call a configuration file for the Kadi server. Again, if you don't know what Kadi server is just a simple HTTP server that you can set up. I mean, it's got great DX, and you can. It's what I wish I had when I was toying around. I think about 7, 8 years ago with the LAMP stack, Linux, Apache, MySQL, and PHP, or what you might call the WAMP stack, because back then we weren't actually using Linux. I wasn't actually using a Linux machine. I was using a Windows machine. So call it the WAMP stack. Um, this is what I wish I had back then, because back then you had to set up Apache and set up the HT access files, and the way you could you know just to set up a simple HTTP server. You had to do all this, do the rewrite command and all that kind of stuff. And it was too much. Nginx made it a bit better, but Kadi server takes the win. This is a configuration file for Kadi server. It's just named Kadi file. It's placed in the root. And this is a local domain that I've set up and registered and pointed to 127.0.0.1, which is the IP address for localhost. So this is what I would use to load this particular HTML file. I've used this domain or this host. And then it's paired with a port number. And of course, this port number is for SSL, TLS, which gives HTTPS, so security and all that. So I have TLS set to on demand, and there's an expiry for this. So you know, um, and I think the expiry is just set to about a couple of hours. So this saves me from having to set up like a perm file for CSS, for TLS or SSL certificates. or maybe even set up Let's Encrypt and all that kind of stuff. I don't want to do that. This is just a simple demo to just show content security policy set up as using a meta tag. So I don't want to do that. So yes, I set up a root config for public. This is in a public folder, as you can see here, and also in another folder called dashboard. But the public folder is the root, and so I'm setting that up here. And then I'm just choosing to use file server. So Kali server can come in different flavors. You can have a file server. I'm using a file server because this is just an HTML file. I can use a reverse proxy. I can set up Cadis server as a reverse proxy to another server and still get to use this, you know. And of course, this I registered this in an etc/hosts file. If you don't know what that is, check in the description. Um, Explaining it right now on this video is beyond the scope of this video. So check in the description. There's a link. You know, um, you can know you can get to know what etc/hosts files are, how to set them up, how to use them, and all of that. Um, so this, whenever we say self in, you know, um, in the content security context here, what we really mean is we just mean, since I've set up, we just mean this. Yeah. So because I've set up TLS, so this is HTTPS, and then this is what I mean whenever I say self, based on my setup, my configuration here on the Kadi file. This is what I mean. All right, let's get this out. So back here, I have this unsafe hashes. Now, unsafe hashes is how you instruct um, uh, it's basically how you instruct content security policy to accept checksums as opposed to URLs. So the URL origins, like this one and this one, I've already explained what self points to in the context of this HTML file, is for basically script tags that have an SRC attribute, something like this. Yeah. So this is script tag SRC attribute pointing to a URL. All right. And this is the origin of the URL right here. And it's the same as what we have right here. So what we're saying is we're telling content security policy, whitelist this particular URL origin and ensure that any script we load on this page is either from this origin or from this one or from script tags that don't have an SRC attribute but have a checksum calculated, which is in this case a cryptographic hash. So the checksum in this case is a cryptographic hash. A checksum is simply how you can be able to verify data. That data is contains what it says it contains and is correct and valid. It's kind of like when you are downloading software, okay? And if you're downloading software, you have this thing called file signatures. Where the binary file, there's a cryptographic signature that is extracted and used to verify that that software isn't from some kind of sort of malicious source, and the signature, the binary file signature, acts as a checksum. So that's exactly what's going on here. So if I come down here, I can see um, a script tag right here, has an ID attribute, has a type attribute set to text slash JavaScript. It has this. I haven't actually done this. This is actually just, you know, empty for now. But it doesn't have an SRC attribute pointing to a URL. So it means we can't whitelist this script tag using a URL. We have to whitelist it using its content because it contains actual JavaScript code. And we have to, you know, uh, generate a checksum from the contents of the script tag. And that checksum is in the form of a SHA-256 cryptographic hash. So what this does is by default, script src just allows you to just have, a bunch of URL origins. But for script tags that don't have src attributes pointing to a valid URL, you can now use this unsafe hashes to instruct content security policy powered by the browser to accept SHA-256 hashes. Uh, I think there are other SHAs that you can use, but I think 256 is actually the common one. And you just have to put it in single quotes like this, just same as you do self. The only one that doesn't need single quotes is just a full URL origin. And I think I have a bunch of them here. Yeah, I have this. And then, of course, we get the punctuation semicolon that ends or separates one directive and its set of values from another. And then following that, we have style SRC. Okay, style SRC is for CSS, so SRC is for source. So we want to set up a list of URL origins for style sheets that can be loaded by this page. So this restriction of you know which URLs are allowed to load specific resources. So the directives map to specific resources like fonts, um, scripts, JavaScript, CSS styles, as we have here, video, audio, uh, images, and so on and so forth. So this is just three values. This has just three values. It had self. And remember what I said about self, all right, with this. So self points to that. And then we're also setting this particular origin, URL origin, as a place where we can load style sheets from. So here's the important thing to note. Any origin that is not listed here, again, this is a whitelist, all right? And each directive points to a given kind of resource. So we have style SRC, here we have script SRC, all right? Any URL not listed here, any URL origin, to be specific, not listed here, and you try to get or load CSS from any URL origin not listed here, the browser is going to throw an error. First of all, it's going to block the loading of that resource, and then it's going to throw an error. All right. So we have self, we have this origin, URL origin, and then we have loading style sheets from fonts.google API. So style sheets from there. Then we have the semicolon that ends this particular instruction for style sheets. And then after that, we have um, image SRC. So IMG SRC. We saw that, from the earlier example on MDN, the MDN site. IMG SRC is for images and just self. So we can only load images from, yeah, this particular, server and all of that, or this particular server serving this particular file. And then, of course, we have semicolon ending this entire instruction. All right. So the directive and the values for the directive make up one instruction. And we've gone through several instructions now. Then we now have font SRC. This is for fonts. So this um, basically shows which origins that we can load fonts from. And we only have one origin here, URL origin here, which is Google Fonts, gstarlink.com. So that's the only place we can load fonts from. All right. And then we have a semicolon, which ends this particular um, uh, directive value pair. All right. And then we have required trusted types for scripts. Um, Trusted types is another aspect of web security, powered by web browsers and powered by the web platform. I think the only thing I can say for it now, because going in to explain what trusted types is beyond the scope of this video. The only thing I can say right now with regards to this is that trusted types is another layer of security, another tight layer of security built on top of content security policy, or CSP for short. And then these are more stuff with trusted types. Yeah, we just have this stuff. So the thing is, just forget about this guy, right? Forget about everything here. Just focus on, the directives and the values, that we're doing. Trusted types, I would have to make a separate video explaining what trusted types are. But for now, just know that they are an additional layer of security built on top of content security policy. But for this video, we're focusing on content security policy. Um, so yeah, so you might ask, why do we have multiple of these SHA-256 hashes? It's because, yeah, this is not the only script tag that doesn't have an SRC attribute and has some content. If we open up the body tag and scroll to the bottom, we're going to see more script tags. This is just some trusted type stuff. This is the trusted types polyfill. A polyfill is, some piece of code that allows us to plug missing features from a browser, especially older browsers, uh, that other browsers support, but the current browser that we are loading the polyfill in does not support. So the polyfill patches that browser with that particular API or functionality or um, feature, so to speak. Uh, in this case, we just have a type attribute. We have an ID attribute saying trusted types polyfill. So that's what is being loaded here. And then we have the hash for it, right? And then we have this pertaining to trusted types. Just ignore that. This video is not really about trusted types. And then we have this one too. This is another script tag. And this is the code I write for trusted types. Now, you can see this event listener being added here. You have security policy violation. Whenever, like I said, the browser throws an error when for a directive and a list of URL origins, you try to load, like for, let's go back up here. Let's say for style SRC. So you can see there are three origins here. There's self, which points to what's in the CADI file. There's this on package.com, and there's this. Anytime you try to load, or if this page tries to load a style sheet from some other URL origin that is not in this whitelist, it's going to throw that error. It's going to throw an error, a security policy violation error, which we can capture by setting this particular um, event listener right here. So we can catch it and we can do something with it. Here, I'm just logging it as an error to the console. Yeah, I have a couple of stuff. So the way to use trusted types is it's usually attached on the window, and this is the object. And then you create a policy. But again, this is not for trusted types. So I'm just showing you script tags without an SRC attribute. And you can see the hash for it is added here. I like to do this where I use a data attribute to just add the hash. And then there's the last one. This is another polyfill for something called the DOM parser. Um, Newer browsers support it, but older browsers kind of don't yet support that. So in case I'm loading this in an older browser, there can be support for that. So like I said, just forget about trusted types. I'll make a separate video about that, you know. Okay, so I think I have one more script tag here. It contains a bunch of stuff, but here I'm setting I'm setting the same event listener, security policy violation. But this time I'm setting an alert. You can see that, and the event object has a bunch of properties. There's original policy, which is, the policy that was set for content security policy. There's the blocked URI. Like, remember, like I said, any URL or URI not included in the list of URIs, right? The browser will throw an error. And first of all, before it throws the error, it will block loading that asset. If it's a CSS file or a script file or JavaScript file, or even say a font file or a video file, it will block the loading of that resource and then throw the security policy violation error. And we're just using window.alert to just alert something to the screen so that we can just take a look at it. Um, so yeah, I guess that's it. Lastly, let's come to default SRC. Remember what I said about default SRC? We saw that in the example used, which we saw on MDN, default SRC was set to self. But the way I like to set up content security policy is that um, I like to set it in such a way that I don't have anything in this bucket. So default SRC, like I said, is a big bucket encompassing all other sources for scripts, for videos, for fonts, for images, for CSS files, all the stuff. I like to set it to none. I don't want anything here. And then I like to specifically set for each other one, specifically for scripts, specifically for styles, specifically for images, fonts, all that kind of stuff. I like to specifically set the origins, or in this case, the checksums. All right. Once I use this unsafe hashes to tell content security policy that I want to add checksums, SHA, uh, cryptographic checksums to the list, you know, to be in place, to be there in place of URLs or URL origins. So yeah, you might say, how do you generate this, this thing? How do you generate that? Well, you generate it by copying the contents of the script tag, or it could even be a style tag, right? Because we can have internal style sheets, set up as style tags. So copy the contents like this, and then you paste it in a text area, you know, at this particular URL, which we're going to be seeing in a moment. So we're going to be seeing how it's used and everything, how we can generate, a SHA, for script tags or style tags that don't have, you know, any URL. And we have to now, you know, make do with a checksum, a SHA cryptographic hash, which would pass as a checksum. You can see what I said here: set up content security CSP, SHA-256, and it's generated here. So it's generated here. Once we load this in a browser, we can just paste the contents of the script tag here, and then we can generate the hash as the checksum. Okay, so we're going to be loading this particular HTML page or HTML file into a browser, see what it looks like, what it looks like. And then we are going to be doing some violations and see what pops up on the alert. And yeah, we're just going to see how that works. So again, this is hands-on. This is an expose, and I really want to do my best to actually communicate um, how this really works. Okay. Okay. So we've loaded this up, and as you can see, this is the index.html file. And then as you can see, this is what we have. Okay.local. We registered it, pointed it to localhost 127.0.0.1, which is the IP address for that. And you can see we have some cool HTTPS, with the padlock there right here. So yeah, this is what that page looks like, right? This is everything in the body tag. So you know, I think I have something nice here, searching for stuff. And we have this. So this is kind of like what you get with something like Google search, but I think this time instead of bold characters with a different foreground color, I think you get this, you know, no bold characters, just a different foreground color. And there's some bit of fuzzy search going on here. So yeah, this is cool. I think you can do that. And then you can do this. And you can do that as well. It's really cool. Anyway, um, let's not get sidetracked. Um, so this definitely doesn't show us much about content security policies. So, but it will in a bit. I'm still going to come back to this page, but let's just hop over to this. So this is the report URI. It's a company. This is the URI that enables us to generate a SHA-256 hash for you know um, uh, the contents of, let's say, a script tag or a style tag. So I have in the clipboard right now a script tag, and I think I'm going to paste that in here. Yeah, I think I might have to increase this. Yeah, so this is the content of the script tag, and once I press this button, I think it's going to generate a hash. Yes. Okay, I think something is up somewhere. Let me try and reload this. So if I paste this and I try to generate a hash, yes, it works now. So this is the hash, and this is what I copy and put into um, the the content security meta tag, um, instruction set. You can call it an instruction set, just as a value of the script SRC directives. So this URL, link is in the description, allows you to generate um, the checksum, the SHA cryptographic checksum for script tags that do not have, like I said, do not have an SRC attribute that you can actually link to. So generally, this is a company. I think they have really nice products. Yeah, they have this, and I think they have all that stuff. PCI DSS compliance. I think that's for fintech stuff. Cryptojacking protection, cross-site scripting. Wow, clickjacking protection, fraudulent email protection. These guys have a lot. Yeah, I think back then they had like a free tier, but I don't think they do. They have that anymore. And yeah, they do have something for content security policy. So I guess if you don't want to roll content security policy by hand, manually, like I have done here, or as I am demonstrating here, you can use these guys. I think, yeah, I think they have this. I think they have a CSP wizard, so a content security policy wizard that helps you just set up what you need to set up, and then you know tells you when you have some vital URL origins that are missing from your whitelist, from your content security whitelist. And we also have a CSP builder. I think this is an extension, your browser extension or something. So yeah, check them out. I think they're cool. Wow. Yeah, they used to have a free tier. Like I said, um, wow, that's really $50 a month. That's wow. Anyway, I mean, if if you want to use, if you want to check them out, if you want to use them for content security policy, just have at it. The link is in the description, right? The link to the hash generator, right? Link is in the description. Check there, and also the link to, like, you know, this. Um, but from this link, you can go to other links. Check them out, see what happens. Um, so now I think we're going to be fiddling with this page, right? That's what's next. We're going to be fiddling with this page, and we're going to try and see how we can break CSP, what happens with a security policy violation. We're going to have the alert, just as I showed you earlier in the code on VS Code, my editor, my code editor. And we're going to see what that feels like. Right now, we don't have any, I think if I inspect, I don't think we have any violations. We just have a nasty type error. We don't have any violations because if you open up the DevTools, if you have content security policy set up on a page and you open up the DevTools, if you have any security policy violations, you're going to find them here on the, you know. Okay, so we're back, and we're back to the file. I guess I've explained this, and I think it should be clear by now, why I set this to none and every other thing that follows. So right now, for this particular script tag, I've set the data hash attribute, right? Because a few moments ago you saw me generate the hash for this particular script, right? Within this script tag, all right? And remember, the way to do it is you start from the end of this, right? And you to the beginning of the closing tag. So you start from the end of the opening tag for the script tag, and then you go all the way, and then you copy this, and then you paste it into the text area on the page, and then you click the hash button, and then it generates the hash for you. So this time I've thrown in something into the works. So if you observe this way, I have a style tag here. I think I can, set this just for, you know, formality's sake. Set this in here. And this is an internal style, right? Just setting scroll behavior on the HTML element. And remember, this is CSS without a URL origin, right? And being that it is CSS without a URL origin, we're supposed to generate, a hash for this. And we're supposed to put that into the style src. Yeah, this point. So you can see that the only thing here is self, this origin, URL origin, and this one. All right. So because we don't have any checksums or SHA-256 hashes here, we're definitely going to trigger a security violation, security policy violation, just because we included this. Remember, this wasn't here before, so we just included it. So what we're going to do now is that we're going to reload this, and that should take some time. Yeah, I don't know. Sometimes Kadi Server does this, but anyway, um, well, not Kadi Server per se, but the alert is doing that because it's blocking the rendering of the page. So this is, the alert. This part, right, is what you call the policy, the original policy. So the original policy is everything, all the directives and their values, right, as you can see here. And down here, I think, um, yeah, it says on inline. Inline is the blocked URI, so it's an inline thing. So that we have inline is used to refer to um, internal scripts, internal style sheets, or even you know uh, style sheets or CSS set with the style attribute, right? So, and then you can see here it says violates style SRC, all right? So you can see that here, violates style SRC. So because we have a style tag that doesn't have or doesn't point to a URL, right? Um, origin, like a given URL origin. Um, and we didn't actually generate a checksum for it. So it complains, and we have that. So what we can do is we can fix that. So how do we do that? Like I said, we copy this out, okay? And once we do that, we can reload this just to clear that. Then we put that in here. Then we click the hash button. So we have that, right? So we copy this, and then we can come here and just say data. I like to just include the hash as a data attribute on the element. So I can do that. Oh, I didn't copy out the single quotes. I need the single quotes. All right. So what that means is that we're going to have to include this. This is what you call a, you can call it a subdirective. This is what allows us to do this. But this is kind of outdated. I think this is for CSP DOM level 2, I guess. Hashes are not really present. So basically, quick history. Content security policy was implemented in levels in across all browsers. So you had CSP DOM level 1, CSP level 1, CSP level 2, and currently we have CSP level 3. CSP level 1 didn't include these hashes. It was just for URLs. As CSP level 2 included the hashes, but this was a way to include the hashes. So you had to do unsafe hash, and you did that and all of that. We now have something called strict dynamic, which is, I think, CSP level 3, that replaces this. And you use, instead of using, because hashes are sometimes considered to be quite unsafe, but instead of using hashes, but yes, they work as a checksum, they work perfectly, but they are sometimes considered to be, you know, um, unsafe. So in place of hashes, we now have what we call N-onces, or an N-once, or a nonce. Some people call it a nonce, some people call it an N-once. We're going to be looking briefly into that. But yeah, these are still usable. Uh, but we can either use a hash like this, a SHA-256 hash, or we can use an N-once for script tags like this that don't have any SRC attribute pointing to a URL, or for internal styles like this that don't fetch CSS from any URL. So we can either use a hash or an N-once or nonce, but we'll get to that in a moment. So let's just fix our security policy violation. So here we're going to say right here, I wonder why that happened. We're going to say uh, unsafe hashes, and then we're going to include this, right? So this is how we fix that, right? So we generated the hash and we fix it using that. Um, so let's go back here and reload this. I think we should be fine. We shouldn't get, yeah. So we don't get the alert anymore. So there are no security violations. But if we, let's say we take this out, again, and before we take it out, let's just look at the console. So we just have this, nothing to it. So if we take this out again, right, and we reload this, so yeah, we have that, and just allow the page to load. If we go into the console, yeah, we're going to see that. So refuse to apply inline style because it violates the following content security policy directive, style SRC, right? And so similar to what we're saying, that's a security policy violation. Um, so anyway, let's take that out. So I just wanted to like show you some of the things that can trigger, the security policy violation and how you can kind of deal with that. So I think briefly we'll be looking at um, an N-once. This is what you call an N-once or a nonce. Some people say nonce, some people say N-once. It's an attribute um, uh, containing some cryptographic nonce, which is a number used once. That's what it means. It's a number used once. So number used once, N-once. Some people say nonce. So it's just different. And N-ones can be used for, they are used for a variety with different kinds of stuff, but you can also use them for content security policy, as we see here, to determine whether or not a given fetch will be allowed to proceed for a given element. And um, yes, the N-ones attribute can help you this subdirective unsafe inline. So yeah, I could this unsafe inline, I could get rid of, to use it, I could get rid of all of this, I could get rid of this subdirective and all of these hashes here, right? I could get rid of everything, right? And just use unsafe inline. So unsafe inline is, this is inline. This is an inline script, right? Because it's embedded right into the markup. And by specifying unsafe inline right here, so we can specify it here, unsafe inline, and then we can get rid of all of these guys. Yeah, we can actually get rid of everything here. We can get rid of this. Okay. Yeah, we won't have any sort of security violation. So we came up here and reloaded that. It still have none. All right, no security violation. But if we took away this, and we have to put this on safe inline because we do have inline scripts here and also in the body tag, right? Like we saw earlier. But if we come and take this away, then suddenly we have, you know, we have definitely we have a security violation. Um, and yeah, it will alert for each violation. So I think there are about 6 violations now or more. Yeah. Um, yeah, the page is scattered. There are numerous violations because there are numerous script tags. So you can see here that there are numerous violations. Yeah, like this is up to about 6 violations in here. So I think in total, I think you have like 10 violations. So six, then you have one, two, three, four. So 10 violations in all. Because we don't have a hash and we aren't using unsafe inline, yet we're using, you know, internal scripts. So the reason why this throws a security policy violation is because what if somebody injects a script like this? There'll be no way to tell if it's safe or if it's something that the website should permit to execute. So in cases of things like stored XSS or reflected XSS, um, you know, a bad actor or somebody trying to, you know, compromise a web page can inject a script using maybe reflected XSS. XSS is short for cross-site scripting or stored XSS, and that can execute a script. And CSP or content security policy, powered by the browser, wouldn't know whether to block the execution of that script, okay, or allow the execution of the script because we've not specified that this script is allowed to execute. So, which is why it proves, that. And generally, the unsafe inline directive, subdirective, I like to call it a subdirective, it, it's not really safe. Yeah, because it allows any script to execute, any internal script, all right, to just execute. It doesn't tell any difference between, it doesn't know how to tell the difference between a safe script with a checksum and one without a checksum included in the policy. Um, so a hash or an N once is how you are able to make that demarcation or make that separation and say, okay, the scripts with an N once are safe, the scripts without an N once are safe, or the scripts with a SHA-256 hash are safe, and the ones without, they are not safe, so block them. So nobody, if you use this unsafe inline directive, it doesn't, it diminishes, it reduces your security. But when you're trying to use something like content security policy, it doesn't really do the job. So that's why it's not advisable to use this. And like it says here, unsafe inline directive, which allows uh, all inline scripts and styles, so which is not really safe. So you can use in if you're using a Node.js server, you can use the crypto module, CommonJS module, and generate this, and this can be your N1s. Generate something like this using the crypto Node.js crypto model, and this is how you set it. So you have some content in the script, and you set the N1s like this. So you can come here, and on this tag, you can this particular script tag, yeah, you can set an N1s and set it to something. But this N1s is better generated from your server. So from the server serving this file, you generate an N1s and then you send that down with the markup. So if you're using something like Laravel or Ruby on Rails, or um, uh, something like Django or Masonite, any of these, yeah, you can generate them. But then, like I said in part two, I'll do a demo of Next.js, both page router and app router, and we'll try to see how we can generate an N1s using a middleware, a Next.js middleware, and also using the next config file. We'll see how we can generate an N1s and then send all that down. When the whole thing is server rendered, you can send all the markup down. with some internal styles. And we'll see that happen in part two of this um, video, right? So let's get everything, back to order, because I think we made some changes here. Yeah, we have that. And let's have that. So yes, this will now take away all the violations, um, right? Because we still have this internal script tags here, and we also have them all the way down here in the body tag, right? And yeah, just like a SHA-256 hash, a cryptographic hash, when setting the policy, as a HTTP response header, we have to set this up, script SRC, and also, tag the N1s into this in this manner. And yes, these are just some security features. You can't get the attributes. You can't use a script and execute and get the value of the N1s. The browser would block it. And also you can't match the script tag, right? If you're trying to do an exploit with CSS, you can't match the script tag in CSS and make a browser request using the background. Yeah, you can't do that. So yeah, that's about this N1s thing. So if we come back here, let's clear this and let's reload this. I think we should have everything back to normal now. It should only take some time. So, and also if we inspect the console, we have no more violations. So what I want you to take from this is the N1s and the SHA-256 hashes are two ways you can, tell content security policy, hey, this internal script or internal style is allowed. Allow this script to execute, load this style, but any other thing that doesn't have an N1s or a SHA-256 hash, don't load it up. Like just block the execution of that style, internal style with a style tag, or an internal script with a script tag. Just block that. So, like I said, we're going to be seeing how to use the N1s, how to generate it. We can generate it using, the crypto stuff. We can generate it using, there are several methods to generate an N1s. The crypto, Node.js crypto module is not just the only way to do it. There's several other ways to do it. But for now, I think you were able to understand how to set up content security policy with a meta tag. Next up, in part two of this video, we're going to look at how to set up content security policy with an N1s and with strict dynamic and all of that using Next.js page router and app router. We're going to look at those two and see how to actually set them up. So I think I have some, some brushing up to do with all of this. So I'm going to do that and prepare, like the second video for this. So I hope you understood everything that has been demoed here, just going through the motions of it. Uh, and yeah, let me know what you think in the comment section. And please, if you enjoyed this video and you enjoyed any of my past videos, please like, subscribe, share. I really need the boost. Thank you very much. And see you guys later.